Let's dive into one of TypeScript's absolute smartest tricks. It's a feature that, honestly, can sometimes feel like a roadblock, but it's actually your secret weapon for writing code that's safer and way, way smarter. It's called narrowing, and together, we're about to crack the case.
So, have you ever been here? You've written a piece of code, you know for a fact it's going to work just fine when you run it, but TypeScript just throws up its hands and gives you this big, angry red error. It's so frustrating, right? It feels like it's just getting in your way. But what if it's not? What if it's actually trying to help you solve a mystery?
Okay, let's examine the crime scene. We've got this pad left function. The padding can either be a number of spaces, or it can be a string that we just tack on to the front. The problem happens when we try to do something that only works on numbers. TypeScript immediately puts up the yellow tape. It sees that ambiguous string/number type and basically says, "Whoa, hold on, I can't be sure this is a number." Our detective has found a suspicious ambiguity and needs more clues before we can proceed.
And that's exactly what we're going to do. See, we're not fighting with TypeScript, we're working with it. We just need to provide a little bit of evidence, a clue, right there in our code that lets the type checker solve the case and move forward with total confidence.
This whole process has a name. It's called narrowing. It's the official term for how TypeScript intelligently watches our control flow, things like if statements, to eliminate possibilities. It takes a broad, kind of vague type like string or number and narrows it down to the one specific type it has to be inside that particular block of code.
So let's look at the situation before we give it our clue. Right now, anywhere inside this function, TypeScript looks at our padding variable, and it only knows one thing for sure. It's either a string or a number. That or is the ambiguity, and it's the source of our whole problem.
And now we give it the clue. Just by adding a simple if statement, checking type of padding equals number, we've given the detective exactly what it needed. What's so cool here is that inside this if block, TypeScript is smart enough to know, hey, padding can only be a number in here. The ambiguity is gone, the type is narrowed, and proof, the error just vanishes. It's a beautiful thing.
Now that typeof check, that's just one tool in our detective's toolkit. TypeScript actually understands a bunch of different JavaScript patterns that can act as clues to help narrow down types. So let's open up the toolkit and see what else we've got.
So here's our whole detective kit laid out. We've got our basic tool for checking a variable's type, which is typeof. Then we can check if it even exists with truthiness. We can get specific by comparing values with equality checks. We can even peek inside an object's capabilities with the in operator or check its family history with instance of. Each one of these is just a different way to give TypeScript the evidence it needs.
All right, let's start with truthiness. Think of this like a detective checking for a pulse. Is there even a value here to investigate? In JavaScript, some values like null, undefined, an empty string, or 0 are all considered falsy. So if you just drop a variable into an if statement and the code inside it runs, TypeScript knows for a fact that the value can't be any of those falsy possibilities. It successfully narrowed the type just by confirming signs of life.
But here's a classic trap that can throw you off your game. Because of this super old quirk in JavaScript, if you run typeof on null, it actually gives you back the string object. Yeah, I know. This used to trip developers up all the time. But it's a perfect example of where TypeScript has your back. It knows all about this little quirk and will correctly warn you if you just check for object, reminding you that, hey, this thing could still be null.
Now, equality checking is where TypeScript's logic just really shines. Imagine you've got variable x that could be a string or a number, and variable y that could be a string or a boolean. So what happens if we check if they're equal? Well, TypeScript looks at the overlap, the one thing they both have in common, and it deduces that the only way x equals y could possibly be true is if they are both a string. So inside that if block, boom, it confidently narrows both of them down to string.
The in operator is like checking a suspect's toolkit for a very specific item. Let's say our animal could be a fish or a bird. Well, checking for this swim property is like asking, hey, do you have the ability to swim? Once we're inside that if block, TypeScript knows the answer is yes, so it can confidently narrow the type down to fish. It identifies the suspect based on what it can do.
So far, we've been using these individual clues. But what if we could structure our data from the very beginning to present a totally airtight case? This is where we level up from being a detective to being a master architect of our types.
First, let's look at a common but, flawed approach. We make one giant shape interface and just make properties like radius optional.
The problem is, even if we check that shape.kind is a circle, TypeScript has no way of knowing that that's connected to whether radius exists. There's just no link between the properties, so it all stays ambiguous and confusing.
The solution is this really powerful pattern called a discriminated union. Now, don't let the name scare you. The idea is simple. We define separate, super clear interfaces for each possibility, one for circle, one for square. Then we give them a common property, usually called kind, which has a unique string value that acts like a label, or a discriminant.
I mean, just look at the difference here. On the left, it's a jumble of optional properties. It's confusing. But on the right, it is crystal clear. A circle always has a kind of circle and a radius. A square always has a kind of square and a side length. There is zero ambiguity. We've explicitly connected the kind to all the other properties. And this is the glorious payoff. When we use this structure in a switch statement, it's like pure magic. The second TypeScript sees case circle, it knows with 100% certainty that our shape variable is a circle, and that means shape.radius definitely exists and is a number. No more errors, no more hacks, case closed.
But wait, a master detective leaves no stone unturned. How can we be sure we've handled every single possibility, not just for the code we have today, but for any code we might add in the future?
Well, TypeScript gives us this amazing special type called never. You should think of this type as representing a state that should be totally impossible to reach. So in our switch statement, after we've handled all of our known cases, we add a default case. And inside that default, we try to assign our shape variable to another variable of type never. And here's the crucial part. If we've correctly handled circle and square, then that default case is completely unreachable. The shape has been narrowed away to, well, nothing, and assigning nothing to never is perfectly fine, so TypeScript gives us no errors. We've just proven that our case is exhaustive.
But here's where we set our trap for future bugs. Let's say, months from now, a new developer on the team adds a triangle to our shape union. They've updated the type definition, but they forgot to update our function that uses it. And boom, the trap works. TypeScript sees that if the shape is a triangle, it's going to fall right through to our default case. And it tells us, hey, you cannot assign the type triangle to the type never. It found the bug for us. It literally forced us to handle the new case, making our code robust and totally future-proof.
And that's really the journey, isn't it? We started out feeling like TypeScript was accusing us of a crime we didn't commit. But by understanding narrowing, we've learned how to work with the type system, giving it clues and structuring our data so it can help us build these truly airtight, bug-free applications. So the next time you see one of those errors, don't see it as a roadblock. See it as your partner, the detective, asking you for one more clue. The only question is, what mysteries are waiting in your code base for you to solve?